Okay, welcome everybody to Go in 5 Minutes, episode 12. Today we're going to be continuing the concurrency series, and we're going to talk about the second problem on the trivial concurrency exercises blog post. So as a quick side note, you can go over to issue number 14 and see where we are in the whole concurrency series of screencasts. So let's get right into the problem today. We're going to be talking very extensively about managing shared state in a concurrent system. So Go has two major ways to coordinate the management of shared state. They have mutexes, which are locks, essentially, and they also have channels and Go routines. So Go routines used in conjunction with channels allow the Go routines to communicate with each other and then synchronize on their progress. Now Go has a mantra which is listed here. That's don't communicate by sharing memory, share memory by communicating. You can read a ton more, and there's a code walk at that link there, golang.org/ref/mem. But essentially what that means is we should prefer to use channels over mutexes or read-write mutexes or the like. And in a more generic case, channels are more likely to be easy to manage and scalable as your code base grows than mutexes. But that's not to say that mutexes are useless or should never be used. Today we're going to focus on using channels though. And as a little side note, if you're at all familiar with the actor model, and I'm saying this because I have a background in the actor model and programming in that model. So if you're at all familiar with the actor model, keep your eyes open. You probably see just a few similarities between what we're going to do here and what the actor model prescribes. And of course, if you're not familiar with the actor model, don't worry about it. You don't need any knowledge of the actor model here today in order to understand completely what we're doing. So let's get right into the code. Let's check out our main.go. We're going to skip over some of the boilerplate here and head right down to line 36 and below. So we've got these four people, Alice, Bob, Charlie, and Dave, and they're sharing a bunch of small plates, a bunch of also known as tapas. So Alice, Bob, Charlie, and Dave each grab one morsel of food from one of the tapas plates, and then they take between 30 seconds and 3 minutes to eat that morsel of tapas. And so of course those shared plates and the morsels on each shared plate, that's the shared state. And we are using a thing called a manager that I'll show you the code for in a second to manage the plates and manage the shared state, the morsels of food on each plate. And then of course we go through each of Alice, Bob, Charlie, and Dave, and we launch a Go routine to simulate each of those people eating. So what's happening in the Go routine is that we're going forever here on line 44 until we run out of food. And then we bail out on line 49. In the meantime, we talk with that manager here from lines 45 to 47. And we ask the manager for another morsel of food, and then the manager responds to us with the name of the food that they're giving us a morsel back for. And then on line 48, if we find out that they didn't give us a morsel back, then we bail out, as I said. Otherwise, from lines 51 and 52, there's a simulation of us eating that food. And now below on line 57, we're using that barrier pattern that we saw 2 screencasts ago. If you didn't catch that screencast, really all this means is we're waiting for all 4 people to finish eating. We're waiting, in programming terms, we're waiting for each of these Go routines to finish. Once all the Go routines do finish, this wait returns, and then we can shut down the manager, which I'll show in a second, and then we print out our closing remarks. So let's go into that manager. Now the manager has a ton of comments. I won't be able to cover everything here, so I encourage you to go check out the comments. The really important part of the manager is here, this Go routine from line 47 to 62. Now this is what we're calling the receive loop. What the receive loop does is every single time it gets a request on this channel, every time it gets a send on the channel, it receives it. The received value is another channel that it can write back on, and that's the response message that it sends. Then it checks to see if there are any dishes with morsels left on them. If there are, then it gets past this continue, and it finds the index of one of the dishes, a random index, and then it gets the dish. It decrements the number of morsels. If it needs to, it removes the dish from that internal shared state, and then it returns the name of the morsel back to the person who requested it. Now, this receive loop, if you'll notice here, it keeps going forever unless someone closes that ch variable. And then, of course, we saw that before. We do close it down here. After every single person is done eating all the morsels, then we're ready to shut down the manager. So we're a little bit over time, so let's see this in action really quick. We're going to build and run it. There's the build, and the run starts here. This is the simulation. Now you can see it's running a little bit faster than the demo on the blog post says, and we're just doing that in the name of time. But you can see we've got this random selection of Dave, Bob, Allison, Charlie eating random foods, and then finally when they're all done, this represents that all the people are done eating, all the foods are exhausted, all the go routines have returned, and the manager has been shut down. So that's all for today. I encourage you to go check out this code, read through all those comments, and then see if you can get a good understanding of all of the channel usage that we've done today. And if you can't, again, please feel free to file an issue. Take care.